Well, well, well! Look who it is!
What's going on, YouTube? So this video is more for my Discord channel. I was telling them that I needed some reflection for a project that I'm working on, and a lot of them were confused, didn't understand what exactly that meant. And I've had this conversation before with other devs in the Discord channel where even if they did understand what reflection was and why it's useful, they didn't know how to do it. So I'm going to finally stop being lazy and do a video that I promised to do a while ago, which is how to write super simple reflection in C from scratch for your projects.com. Oh yeah, by the way, join the Discord, like, subscribe, all that stuff. Cool. So here we are in boomertext. All right, so what we want to do typically for a reflection system is that we have some kind of complex object, some kind of struct that you've made, and you want to pass it into something that will give you some kind of information about what the contents of that struct is for a particular instance and what the types are for the contents that are provided. So let's say you have some kind of struct, and let's call it thing, because we're creative here. And let's say that it has a uval and it has an fval for a float. Let's say that it has a character pointer for a name, and let's say that it has some other kind of struct, another thing, and let's say that thing has a int32 sval, and we had some kind of function that was print object, and we wanted to pass in a generic object, the void pointer, and we should be able to pass in any object that we have in our game or our app or whatever, and we should be able to get that information and print it out. We should also have some kind of serialize object if you wanted to do something like that, where you could do the same thing. You could iterate through for property in properties, write property to disk. Be able to do something like that. And then over here it would be display prop in GUI or command line. So how do we go about doing this? This seems challenging. And yeah, it can be kind of a mind bend if you haven't done it before, but it's real simple. It's actually only going to take about 150, 200 lines of code to do this whole thing. Okie dokie. So let's go ahead and get started.
None of you bitches, got these exclusive Swisher Sweets hugs. What's poppin'?
All right, so the first thing that we are going to need is some kind of information about primitive types. So that's going to be your uint32s, your floats, your int32s, your doubles, things like that, okay? So we're going to go ahead and give us an enum, and we're going to call it a meta property type. Again, very creative. And we'll just go ahead and start defining types. So let's go ahead, and I'm going to write up all of these types to be displayed here as elements of this enum. And with the magic of editing, we're going to go ahead and fast forward through this. And we're done. Okay, so we have all of our base types listed here and accounted for. So we got U8, U16, U32, all the way down to our size T. I've also included a string type here because I think it will be useful to be able to designate between different pointer types, base pointer types, right? So if we have like a void pointer and a size T or an int pointer or something like that versus a character pointer, because we might want to handle those things differently. So we can allow the user to have that. And then a standard convention that I always do with any of my enums is that I cap them off with a count. This is so that you're able to use this as a way to be able to iterate through the enums should you need to. You can also do stuff within the GUI to let you know how many enums you have of a particular type. It also lets you do static arrays. So if you have some kind of, let's say, float array for some reason, and you want it to be representative of every single one of these types, I have no idea why, but let's just say you do, then you could statically define it as this, and the compiler loves you for it, so that works. So the next thing that we're going to define is actually something that we're going to use for our meta class information. Okay, so if I give you a quick breakdown of how this is going to work, we're going to have something called a meta registry. It's going to hold a collection of meta classes. Each of these classes holds a collection of properties, and then each of these properties holds info about it, and that's going to be an info type. So let's keep that there so you can look at that. So what the info type is going to have in it, actually if I go through here, is that we're going to want a display name of some sort, and then also a unique ID that'll let us associate the info with a particular ID. And that ID is going to match up to one of these and also match up to any custom types that we let the user do. That way this can be fully extended for custom user applications. So let's go ahead and keep going with this. Next thing we're going to want is, again, this info type struct. We're going to define that here. So let's give us a meta property type info t. And what is this? Well, like I said, we want some kind of display name, so we'll call that just a name. And then we want some kind of unique ID. And this is going to, so we have our display name here. And this unique ID, again, it matches up to the property type, and it's used for lookups and switch statements, which we'll show that off here shortly. Okay, cool. And if we keep going down the line, again, so we're going to have a meta registry, and inside of that registry, we're going to have a hash table of uint64 keys to our meta class values, and that's going to be our classes. Now our meta class, I can't type. Our meta class is going to be, we'll give it a name because it'd be useful to have some kind of display name. We will have a count for all the properties that we have within our property map. So count of all properties in list, array, whatever you want to call it. And then we're going to have a meta property list. Cool. And then above that, we'll finally define what a meta property is. And the meta property, again, will have a name. It'll have an offset into the struct in bytes, and then it'll have our type info. And this is everything that we'll need in order to continue going forward with a reflection system. We will need one last thing, and that is a couple of convenience mechanisms. This is for whenever we actually at the beginning want to register some meta information for a particular struct into a registry, and we'll use something called a class decal. This isn't necessary for the system. This is just something that I tend to do for initializing types. That way you can pass in a single pointer to something, and then you can store all of your information in there that you're actually interested in. So for this, what we're going to do is have a meta property array that we will pass in, and then we'll have the size of that array in bytes. So what we'll do is we'll have a function here that'll be externed, where we're actually going to create a meta registry and pass that back. This will be our context. It'll store all of our information about our meta information or reflection system inside of this. We'll also have a way to free our registry because we want to be good programmers and care about freeing our data. One thing we're going to do for this header file is something very similar, actually exactly like what Sean Barrett does for his DS library, is we're going to make it an implementation file as well. And the way you do that is you declare some section of this file as the implementation, like so, and you wrap everything inside of that implementation within an include guard. So what we're going to do is we're going to define something called meta implementation. And if this is defined, then the thing that's including it will actually define all of the stuff that's inside of that include guard. Hope that makes sense. So we're going to now define these functions. Now the usefulness of this is that we don't have to have multiple files. We can have a single header file, drop that in. We don't have to add it to our build system. So I don't need to come over to this and add it into this file. I can then just have it here, and you can include this file in multiple places within your project. You just have to define this once and you're good to go. So what we'll do is actually define our meta registry. So let's go ahead and define this, and since we're just in C, we'll just declare it as this, and for now we'll just return it. And then for freeing the registry, we'll handle this in a little bit. But it's going to be going through our classes and freeing everything. So now when we come back into main, we should be able to define our meta implementation and then include our meta.h file. And if we get rid of all of this junk up top, and there we go. We should be able to create now an instance of our meta registry. And if we actually do the if def correctly, not if not defined, actually defined is what we're interested in, then it should actually find that now. And we should be able to run this. It should be fine. We're not doing anything, but it does create this, and we're good to go. Okay. All right, so now we need a way. Let's actually start getting it to where we can start pumping information into our meta class registry. Okay, so what we're going to do is actually define a couple things here. So we're going to do a couple of macros here. It's going to be some macro magic. If you're not comfortable with that, I'm sorry. But this is how we're going to be able to do generics in C. And it's pretty cool. So let's check it out. So we want to have a way to be able to register a new class in our meta system. So we're going to pass in a pointer to the meta. And then we want the type of the class that we're actually interested in. And then we're going to pass in that decal, which is this meta class decal that we have here. And I'll put that down here just so we can see that above us. So what we're going to do is call into an actual function here, meta register class implementation, and we're going to pass in the meta, and then we're going to pass in a toString function. So we're going to stringify this argument, and then we'll pass in our decal. One thing that's really important to note about C with macro type of stuff is that you tend to want, depending on the argument and how you're using it, but you tend to want to wrap your argument or your parameter that you have in your macro within parentheses. This tends to help the compiler out quite a bit, especially when you start nesting macros together. Just do it. You'll save yourself a lot of headaches in the future. So what we'll want is to define this function, extern void register class implementation, and what it wants is a const character pointer, and that's going to be the name of the class that's been stringified. We're also going to pass in the registry itself because that's where we're registering this information, and then we're going to pass in the decal, and we can make this a const as well. So the meta class decal. And if we're down here, we can actually start defining what this function should be. What we want to do is make some kind of key for our meta registry for this particular class. And that key is going to be some kind of uint64 lookup that goes along with a meta class. What we can do is design our meta class here. We'll call that class, and we'll do an empty implementation. And we have a couple things that we want to fill out for the meta class. Let's go up and look at that again. We'll just copy this so that we know what we're filling out. So we want the class's display name. That's going to be name. We've passed that in at the top as a const character pointer. We also want a property count. So the way that we're going to get that is actually from the decal. So the property count is going to be the size of the decal for properties divided by the size of a property itself. That'll give us a property count. And we're going to use that a couple times, so let's go ahead and just store that up here. Now the actual properties that we want are going to be malloc. And that means that we're going to heap allocate a large chunk of memory for the array, and then we're going to store all the properties inside of that. So what we're going to need is standard lib.h, and this gives us malloc, realloc, free, all that kind of stuff. But really we're just interested in malloc and free because we won't be resizing anything. Okie dokie. So now if we come back down here, for the class we want our properties to actually be malloc, and what we're going to do is malloc that with the total size in bytes of all of our properties, our class name, and then we are going to mem copy the properties with the properties that we passed in, and total size of bytes will be the size of that decal. Now we want our key. So we've made our value. Now we want to make our key. So again, the key is going to be a uint64, and what we're going to do is hash our name into a 64-bit identifier. And I believe stb has a hash string function, and this gives you a size t, which in our case works just fine. So we're going to use this for the seed. I guess for the seed what we could do is just pass in a seed of 0. We don't necessarily care what the seed is going to be. But our ID is what we care about. So let's go ahead and capture this as a uint64, and we're going to pass in our name as this. Now what we're going to do is insert key value pair into our hash table. And again, we do that with hmput, and our hash table is the meta registry classes table, the ID, and the class. And just as a convenience for the user, we could return the ID if we wanted to and they wanted to capture that. So let's go ahead and do that. All right, so we need a couple more things now. So now we have the ability to be able to register class information, kind of. At least we have the bone set up for it. The only thing that we're missing now is actually setting up this declaration. And what that's going to require is one more thing that gives you information about the structure of the struct that you're actually interested in reflecting. So if we actually look at a structure, again, let's go back to our example over here. We have this guy here. The way this is laid out in memory, at the address of the struct is the first element of that struct. This is guaranteed to be the case in C. This is why C is such a great language, is its consistency with expecting stuff like that. So the first element is going to be the address of thing itself in this case. So it's going to be uval. And if we keep going down the line, these are going to be sequential in memory. So then we'll have fval after that. And then we'll have this pointer here. And then after that, we'll have the other thing. And if you follow that down the line, the other thing is also the same address as its first element, which is sval. So in memory, thing is just a sequential order of all of these elements in memory in one big block, basically. That's how you can think of it. Why is that useful to us? Well, because we can give some kind of offset from the starting of that base pointer to any of these values or any of these elements in the structure, and we can get a pointer back to that element, which if you don't understand why that's useful, hopefully in a second you'll see why that's very useful. Basically means that we can grab any of this data at any point, just given a base pointer and an offset. So what we'll need is actually some way to do that offset operation. And it's actually very simple. STB actually provides one within the DS. It uses it, but we're going to go ahead and write it because it's really simple and it will help you kind of understand what's going on a little better. So we'll call it meta offset. And we're going to take some kind of type and then an element in the array for that particular type. What we're going to do is we're actually going to take the type pointer and get the base address as if it were at 0. And then what we're going to do, let's wrap all of that, is grab the element that we're actually interested in, forward in bytes. Okay, so we're at 0, and then we go forward in bytes for that element. And then what we want to do is we want to take the address of that element, wrap it again, convert it all to a size t, which will give us byte address in size t, which will give us the amount of bytes, right? So you take that byte address, subtract that from 0 because you're starting at 0 in an offset. That gives you the total number of bytes that you'll have. Okay, so what we can expect is that if you take thing here and we do meta offset thing t, and then we pass in uval, this should give us 0. And just to show that I'm not totally crazy, let's go ahead and print that out. All right, so I didn't format this correctly because again, I'm an idiot, but if we look at this, uval has an offset of 0, fval is an offset of 4, name 8, and then oval is an offset of 16 bytes. Exactly like I said it would be. Awesome. So let's move forward. So what do we need now? Now that we have the ability to get the offset, when actually creating the decal, it's going to be very simple. What we want is, again, if we look at the actual meta property, what is this actually going to give us? It's going to give us a name, right? The display name of the field, the offset in bytes into the struct, and then type info to kind of describe what this type is going to be. Let's define a helper macro here. And again, we want this to be generic, so we're going to use a macro. We'll call it meta property. And what it's going to do is take in some kind of class type, and then a field to that class, and then a type for the property. And we're going to call into an actual implementation function. And we're going to do is, again, stringify. We actually haven't designed this function yet, but we're going to put it here where we're going to stringify the field. We're going to get the meta offset of the field from the class. So again, just like we did a second ago, and then we're going to pass in the type info. Okay. This function is going to look like this, where it's actually going to pass back a meta property. It will be externed. And so we're going to need the name of the field. We're going to need an offset in bytes, which we'll get, and then we'll get our meta property type info and pass that down as well. Okay, let's go ahead and make this toString function. It's super simple, where you're going to take in some kind of type and then stringify it. This for the preprocessor is where you do a single pound sign and then you do the type right after it, and then we're just going to cast that to a const character pointer. Let's go ahead now and start working on this function. Not meet property, that's a different thing. We're going to make the meta property, and again it has a display name. Let's go ahead and copy it right here. Go ahead and put that down here just so we can see our fields. So our name is going to be the name, the offset is the offset, and the type is our type. Couldn't be simpler. We've got the ability to be able to set up meta properties, kind of, not quite. We have the ability to be able to register classes, kind of, not quite. What we're missing now is the meta property types, right? So we have this declaration here. We have our property types. We have the type info structures, which give us the ID and also a display name. What we don't have is a way to actually create these things just yet. So let's go ahead and do that, and that'll tie everything together. So again, we're going to do it just like we did before, where we are going to have a useful macro, which is going to be a meta property type info decal. We're going to take a type and then a property type. So we'll have a base type and then a property type, and what we'll do is we'll actually have again a implementation function where we actually do what we need here. And we're going to stringify our type and then pass in the prop type to this function. So this function again will be externed, and it will return our meta property type info, and we expect a const character pointer name from that, and then we expect a uint32 ID. If we come down here to fill this out, so the name is going to be the name, the ID is the ID, and return the info. Now what we can do is start providing some useful defines. What we're going to do is, when actually declaring these declarations so we can pass that into the registry, we're going to have to declare a lot of stuff. So it would be useful to be able to have some of this stuff kind of defined for us. So let's go ahead and do some defines for our base types. So we have our U8, and we'll pass in some type decal information. So this is a uint8t, and it's going to take the type of U8. Crazy, I know. And I'm going to fast forward and finish all these out. All right, so we're back and I filled all of these out. So we have all of our type infos defined in these nice little packages that the user can include, and it will create these little structs for you and then be able to use that inside of the class decal that we're going to use to register our classes. And if you notice, all the type infos match up. So what we're passing in here is the actual base type that we're interested in. So the actual uint8t primitive type, and then we have the meta property type that we're interested in, which is going to map to a uint32 ID. This might not make sense right now, but it will make a lot of sense in a second whenever we're actually using this and then using it in a switch statement so that we can know what type we're interested in and know how to grab the information for a given property. All right, one thing I need to note here is that we need to get rid of this semicolon. That's going to mess everything up, so get rid of that. Okay, so now we should be able to start actually registering class information about our structures here. So let's go ahead and do that. If we come back over here to meta.h, we have a register class macro. So let's grab that. And what do we want to pass into here? Well, we want the address of our meta object. We want the type of the class that we're interested in. In this case, we'll do thing t. And then we want the decal, and we're going to pass that in as a pointer. And then we can do initializations of structures in place and then pass them in as pointers as well at the same time. So we want a meta class decal, and we're going to have to wrap that all inside of parentheses. That way the compiler doesn't complain. But actually you can see that this will compile. So now what we can do is start filling these out. Okay, so our properties we actually want listed as, I keep saying GS because I'm so used to typing gunslinger stuff now, but I'm not right now. So we have a meta property array that we actually want to pass through, and then we want the size of the array. And so that's going to be size of a meta property times however many elements we're going to have for this array, and make sure that compiles. Gorgeous. So let's keep moving forward. So again, we have a meta property macro here that we're going to fill out, which will define a meta property and return it back to us. And this macro, again, is taking the class of the struct itself, which is thing t, the field that we're interested in, which is uval, and then the type, right? So the type info. And if we look up here, it is a uint32. So we're going to use uint32 for our type. So we have meta property type info u32. And for now, we'll just say we have one property. We should be able to compile that. It does. Okay, so we need a way to be able to grab a pointer to the meta class information. So let's go ahead and make that. And that'll take a pointer to our meta registry as well as the type we're interested in. And we're going to call into a meta class implementation. We'll pass in the meta object, and then we're going to stringify our type just like we've done before. And then here is the function we actually want to fill out. It's going to be a pointer to the meta registry object, and then a const character pointer, the actual name of the type. And if we fill this out down here, so we want to actually get a pointer to our class so that we can use it. So what we're actually going to do is grab a pointer to our meta class information. We're going to pass that back so that we can use it for other functions. So we have an hm_getp is what the stbds library provides us, and we're going to pass in the actual hash map with the key that we're interested in. And this key is going to be our uint64 ID. That ID is going to be the string like we did up above with a seed of 0. Cast that to a uint64, and then we're pass that in. So what this is going to give us is actually our structure back that we placed in. This is how it's stored in memory. This messed me up the first time I used this library, but it doesn't actually give you the value back. It gives you back this struct, which is going to have the key and the value. So what we're going to do is not pass back this, but we're going to pass back actually the address of the value that it passes back to us. And back over here in main, we are grabbing that class, getting the count, and then we're going to print that out, and we'll see what she gives us. So we have 1. We should have 1 property, and it does. So now with this, we should be able to iterate over the property count, and we should be able to grab our meta property at the ith index, get the address to that, and we should be able to get some information about it, namely the name of it. We should be able to get the type name, and then we should be able to get the type's ID. Okay, so let's go ahead and print that out. So let's get the prop, and we'll do the name, do the type, and then we'll do the type ID. Okay, so we have our name, which is uval, right? So we have that we've registered with it. It's a uint32, and type ID is 2, which again, if we come back over here and we look at the top, we should have 0, 1, and 2 for this ID. So those line up exactly how we expect it to do. Cool. What we can do now is actually use that information to get the actual values for a particular struct. What we'll need is to have some kind of way to be able to get values back, and we'll do the same thing we've done before. We're going to define some helper functions here for us. Namely, we're going to get the value back as a pointer, and what we're going to do is pass back an instance of the object. We're going to pass back the type that we expect the value to come back as, so the value type, and then the actual property that we want. And this we're all gonna have to do in line as a macro. It's gonna get a little hairy, stick with me. So what we're gonna do is take the object pointer as a base pointer, and we're gonna grab the property's offset. Now we can't just take the pointer itself and try to do some pointer arithmetic. We're gonna need to cast that to an actual uint8 pointer. So that's what we're doing here. And then we'll take this entire thing and then we'll wrap it in a cast where we're going to actually cast it to the type that we're interested in, which is this type here, and then wrap that entire thing. We can also do another version of this where we get a copy. So instead of a pointer, we get a copy of that. And so all we're going to do is we're going to convert that into the type pointer, same thing that we have here, except we're going to dereference it. And then that'll give us, again, so we get the pointer at that particular offset in memory, but then we're going to dereference it as that type. And so that'll give us a copy of that data. So now what we should be able to do is, now that we have the properties information, basically, I told you earlier that we're going to be using switch statements. This is where this is going to come in handy. So we should be able to grab the properties type ID and then do a switch on that in order to get certain information. If we do a meta property type u32, right, we should be able to get a uint32 value using, not meet, using that function. Was it meta registry? Meta registry. And right now we do not have an instance of an object, so we're gonna have to fill that out, but we're interested in a uint32 value at this particular property that we have cached off. So what we're gonna do is create, very simply, we'll create an instance of our thing thing, and we'll set the uval to be 42069. I'm an adult. All right, so then we'll pass in the pointer to the thing, I think. Yes, so we pass in a pointer to the thing. That should give us our value, and we should be able to, assuming that we didn't crash anything, point out the value, or print out the value that we have. If we run this, there we go. Now we have the value. Again, so how did that work? It grabbed the base pointer of our object, grabbed the offset that we get from the property. We switch on the property type, right? Grab that offset, and then we get the pointer to that object, cast it as the type that we're interested in, and we're good to go. So now we can fill this out with other things. Let's say we have an fval, and we'll fill that in with hi for our character name. And then we'll do the oval here in a second, because that's going to require something special, but it really is the thing that'll make this system sing. It'll make it really customized to whatever project you're doing. So let's go ahead, and I'm going to jump forward and fill out these other types. All right, so we jumped ahead, and I filled out the switch statement for 2 of the other types. So we're looking for our floats, which is our F32s, and we're going to print that out. And then we'll do the string as well. We're going to grab that as a const character pointer and point that. We can't forget that we need to add these properties into our property list for the meta class information. So we're going to do that. Say that we have 3 properties that we're interested in. And now when we compile and run this, we should segfault. And there's a couple things I messed up here. You don't dereference a const character pointer. That is stupid. And then for this, this is why we have 2 different versions of this function. We don't actually want to get a pointer to this value, because then that would give us a double character pointer and give us garbage. What we want instead is we just want the value. We just want the value, which is a const character pointer. There we go. So now we have our name. So for this, we're going to get the property's name, and then we'll do the type name, so the display name for that, and then we'll do the property as well. And we'll do that for each one of them. And there we go. And so now when we print that out, so now we see we have the field name, so uval, fval, and name. We have their types as display names as well. And then we have the actual values that are being displayed. Perfect. So the last thing, and you can take this all the way to the bank if you want. Actually, let's go ahead and let's throw this inside of our function here, because this will be useful to us in a second. So we grab the class, and what we're going to do is dump that inside of here. And we're not going to serialize. I'll leave that as an exercise to you. And we'll pass in our object into print object. So we want thing and then the class. And then for these functions up here, we're going to pass in the object pointer to that function. So again, we get the same thing. Perfect. And if you wanted, you could, again, fill these out with all the different meta property types that you had. That way, any object that you had, you could fill that information out and then get it. One thing that we will need is the S32 type. So I'm going to fill that out. And we're not using it for this object, but it will come into play here in a second. What I was saying a second ago is that it's actually useful to be able to register custom property type information, right? Because what we need is some way, we have this other thing that's included inside of this thing value. We don't really have any properties that will cleanly align with that. So what we would like to do is be able to register some what we'd like to be able to do is register some custom information about this property type that we can use in that switch statement. So let's go ahead and do that, and registering all of our stuff. So let's go ahead and do that. So what I'm going to do is define a custom type here. So again, imagine this is your project and you have your meta library that you can use. You can include this in anything, but you have something that isn't included inside a library. You need something custom. Well, I got just the thing for you. So what we're going to do is, again, remember that at the top of here for this type, we have a meta property type count. And the way that enums work is that they will start at whatever the base value is, and it will continue to increment in integers +1 for each one, right? So if you have 7 values, then the last value will be 6, assuming that you started at 0, like a sane person. So if you go down to here for this count, this is actually an integral value, and we're going to use that with some trickery. So we're going to grab the meta property type count, and we're going to add 1 to it. And that's going to be the starting index for any custom types that we want. Okay, and then just like the other stuff where we had these useful macros to define this for us, we're going to do the same thing for the object. So we'll have meta property type info decal. What are we interested in? Well, we're interested in this other thing. So we're going to use that as the base type, the actual defined type that this thing will refer to in terms of property. And we're going to pass in our meta property type that we just defined, which is the meta property type object. So again, all this does is that this is going to get created into a string so that it's going to be the type name that will be looked at as a display name. This is the bit of information that is actually used for associations that we're actually interested in using. Now that we have that, we can do a couple things. We can actually create our oval, and it has an sval, and we'll give it -380. And then what we need to do is include our final meta property into our properties list, and that is going to be oval with the property type info of object. And now we have 4 properties that we're interested in. And if we compile this, should be good to go. Now we're not actually capturing any of that. So what we're going to do is we're going to look for that particular case in our switch statement. So we're going to look for the object type. And so now we know that we're looking for a particular object and we know what type that object is, because we've associated that other thing with this identifier. So what we'll do is we'll grab that object. So it's going to be a const other thing t pointer. We'll just call it v is meta registry get vp. We're passing in the object pointer and we're interested in other thing t at property. Now what we need to do also is that we want to be able to pass this in to this same function and then print out its properties, right? So what we're going to do is we're actually going to grab its meta class for this particular object. And well, it looks like we need the meta class information. So we're going to pass it in as a first argument. Make sure to pass it in down here. And then up here, we're going to grab that and we're going to grab the class at other thing t. That should give us our class. We have the value. And now we can do print object with the meta. We'll pass that, pass in this value, and then we'll pass in our class information. And assuming I didn't blow anything up, and the last thing that we have to do is we need to make sure that we register this class information as well so that we can use it in our function to get this class. So let's go ahead and say that this is thing t registry and this is other thing t registry. And other thing is very simple. It's a single property and it has sval, and that is an S32 or signed 32-bit integer. And so now we've registered those 2 classes. Now we should be able to print out our information, and we are. Here we go. So now we have, this is the other object that's printing it out. It's doing recursively. Let's go ahead and print that object out. So we'll just do like we've done up here, and we'll say that we're doing the property's name and the type. And in this case, it's going to be oval with the other thing t is the type, and then it recursively goes down and it grabs the values of the oval, which is -380 at sval. And so there we go. Now there's a couple things you can notice that this starts to get a little hairy, because a lot of this, it's a lot of typing. It can be, you're manually doing this. And it's also quite possible to mess things up really easily, right? You forget to put something in here, which I've already done a couple times during this example. You forget the size of this array, et cetera, et cetera, et cetera. So one thing that you can do to make this a little bit bulletproof for the future is that you actually write some markup to generate this kind of code. So this kind of stuff wouldn't be handwritten. You would actually run a process before you compile your project to go through and read through your code and then generate all that code for you. That is a conversation for another time. That would make this video much longer than it already is. But hopefully this kind of gave you a bit of an insight into how to do this kind of thing. Hopefully you can kind of see how powerful this kind of thing is, right? You can drop it in your project, start marking up all of your types, and then you can start dumping them into debug, GUI, print stuff. You can throw it in your editors. You can throw it in your serialization mechanisms, you know, deserialization, whatever, any of that kind of stuff. So hopefully you got something out of this. If not, why'd you watch all the way to the end? That's kind of weird. Yeah, so like and subscribe. If you're interested in this kind of thing, join the channel, join the Discord channel. We talk about this kind of thing all the time. I'm more active in there than I am on YouTube. It's just easier to jump on Discord and talk to people. So jump on there and come hang out and say hi and other stuff and things. Cool. All right. Bye.